Hello, so this is a presentation by Group 14, and below are the index numbers of students who helped to make this presentation successful. So our topic is production of gasoline from biomass. So we'll be talking about how gasoline is being produced from biomass, and you can't wait to hear about this. We have a lot in stock for you, so let's continue. Okay, so the content. So we'll give the introduction about biomass and gasoline, also talk about the uses of gasoline, the process description, gasoline from biomass, other units within the company's site, hardware components that are relevant to the production of gasoline from biomass, the software requirements, the computer network, and connectivity and topology. Okay, so uses of gasoline. So one, it says that it can be used to fuel cars, motorcycles, trucks, and our vehicles. So that's what we can use gasoline for. And with the point two, we have that it serves as a raw material for producing petrochemicals, using making plastics, synthetic rubber, and other industrial products. And the three says that it can be used in portable generators to provide electricity, meaning that gasoline is really important. And therefore, if we only depend on the production using crude oil, it wouldn't be beneficial or that helpful to us. Therefore, there has to be another way. And that's why we are going to talk about the production of gasoline from biomass. Okay, so process description. Okay, gasoline. So, number one, you have biomass feedstock. So with this part, the the biomass, the example of biomass that we give, like the food waste, the grasses, they are being collected, dried to make it easier to process. Okay. I have the pre-treatment unit. Okay, so the biomass undergoes size reduction, the grinding, and drying to reduce moisture content. So this improves the efficiency of the gasification process. That's what I said, that it makes it easier to process when the biomass is being collected and dried. And gasification is a process whereby the biomass is heated with limited oxygen to produce syngas. That's a syngas is a mixture of hydrogen and carbon monoxide, and also methane, as we have here. So this causes breakdown of complex organic molecules into partial oxidation. I have gas cleaning and conditioning. So the raw gas contains impurities, and therefore they need to be removed to make the gasoline refined. Okay, so when the syngas is produced, what we do is that it's being treated with a catalyst. A catalyst like the Fischer-Tropsch synthesis to convert it into a fuel like gasoline. And with this, like I said, that's here the Fischer-Tropsch synthesis unit. So this is where hydrocarbons are formed. That specific catalysts help convert syngas in a liquid fuel mixture, which includes gasoline-rich hydrocarbons. And also, as when the syngas has been passed through this process, there is going to be a separation and refining. And it means that probably there might be impurities in the gasoline that may be produced, and therefore the impurities need to be separated so that the gasoline will be refined. And that's why we go through this process. And after that, we store our gasoline. So other units within the company site, so you have biomass receiving and pre-treatment area, the gasification and conversion section, control room, product storage tanks, administration block, utility and maintenance area. Okay, we move on to the hardware components that are relevant to the production of gasoline from biomass. We have the input devices, output devices, and other hardware needs. So the input devices, they all have their functions. So let me talk about some of the functions of them. Okay, so we have the level sensors from the input devices, and that one monitors levels in storage tanks and process vessels. And we also have the gas analyzers. They monitor syngas composition. We have the phase scanners that control access to restricted zones. We have the pressure sensors and the temperature sensors. Sorry, and we have the output devices. So output devices. We have the status indicators, so that they show equipment status, whether they be on or off. And you have the alarms and sirens. That's the warn operators of critical deviations. And let's move on to the other hardware needs. So with that one, we have the CCTV cameras. That's for security and process observation. We have the SCADA services. That's they collect, store, and visualize plant data. Okay, so next slide, we are on the software requirement. So the software requirement, one, we have the process control software. So where this is where we have the SCADA, that the supervisory control and data acquisition. We have the DCS, that the distributed control system, and we have the two, the simulation and modeling software. That's where we have the Aspen Plus, the ChemCAD, and the three, we have maintenance and asset management software. We have the CMMS, that's the computerized maintenance management system. We have for data analytics and reporting into security and access control software. So if you want to get more about these software requirements, you can get them from our Word documents. So computer network connectivity and topology. So the network type, we have the wired and wireless connectivity type. A hybrid of wired Ethernet and wireless connectivity is ideal. So wired connection should be used for critical systems, that's the DCS, PLC system, while wireless access can be used in non-critical zones. Example, the administration area. So suggested network topology, that's the star topology. In a star topology, all devices are connected to a central switch or router or server. It is the most suitable for chemical plant use. One is easy to troubleshoot. It's also centralized control and also high performance. Summary of the network components. So with the components one, we have the router and switches. So that the function of that is to manage data traffic and connect our devices. We have the firewalls. They protect against cyber threats and unauthorized access. We have the servers. They host SCADA software, databases, and system backups. We have the Ethernet cables, and what they do is they connect the physical medium for wired connections. And lastly, we have the wireless access points. They also provide Wi-Fi coverage in admin areas. Thank you very much, and I hope you really learned a lot after this presentation. Bye.